Okay, so now let us discuss the new topic.
Hmm.
That is polymers. Let me just rename that title.
Yeah.
So let's start with the polymers. The polymers is very interesting. Just imagine we have molecules which can so easily make bonds,
Hmm.
and they can make so big molecules like macromolecules we call it.
Hmm.
Like small atoms they combine, they make so big chain, and they form the polymers.
Hmm.
So polymers is a very interesting field of study. Now we will be discussing polymers from the context of electronic materials. So polymers. So let us try to explore the polymers.
Hmm.
Okay. Some properties. So what are polymers if I ask? So polymers are basically macromolecules,
Hmm.
like large molecules,
Hmm.
macromolecules. And these macromolecules are comprised of small, simple, repeating units known as monomers. So polymers are macromolecules consisting of monomers, or made up of macromolecules made up of monomers. And what are these monomers? These monomers are basically repeating structures, simple repeating units. These monomers are simple repeating units. If you want to
Hmm.
like feel the pattern in the nature, then this polymerization or the polymers gives us a very good feeling of it. Like for example, the polythene which we use,
Hmm.
that is polyethylene, polyethylene, polyethylene. So it is polythene. It is basically a combination of monomers. And here, what is the monomer? Here in the polyethylene, the monomer is the ethylene, or we call it ethylene. That is double bond. CH2 double bond CH2. And we have n units of it. And these units of it will combine with each other. This is the monomer in the polyethylene.
And it's very difficult to break the bond.
It is very hard.
Hmm.
And just see polythene which we use in the daily life.
Yeah.
It is very strong. So this polythene, it gives us some interesting compound. Let me compound. CH2, CH2. This is a repeating structure. CH2, CH2, it is so strong, it will keep on repeating these monomers. And this is the polythene, that is the polyethylene. So now it is very clear to us that when I talk about polymer, in polymer, it is made up of two words, polymer.
Mm-hmm.
Poly means many,
Mm.
poly means many, and mer means monomer, repeating. Mer means repeating. Poly means many, plus mer, that is the repeating.
Mm.
So simple repeating units, they keep on repeating to form macromolecules. And those macromolecules are known as polymers.
Mm.
And one very common example which we use in our daily life,
Mm.
that is a polymer. And this polythene, or we like call it plastic also.
Mm.
Plastic is also made up of these polymers only. They are macromolecules. They are so hazardous, for the environment, that they don't decompose. They don't get decomposed.
It takes a long time.
Yeah, like it is difficult. Like they cannot get permanently destroyed, and
Mm.
hence it is harmful for the nature.
Mm.
Now we will discuss polymerization. Now we'll discuss polymerization. So polymerization is a name of the reaction
Mm.
wherein we synthesize polymers.
Is that a difficult process?
Yeah, somewhat difficult. Somewhat. Yeah, really. So it's a chemical process.
Mm.
Polymerization is a chemical process. Chemical process leading to the formation of polymers.
Mm.
So synthesis of polymers, any reaction we do, that is polymerization reaction. So
Mm.
polymerization is basically a chemical process, means it's a chemical reaction which
Mm.
leads to the formation of polymers.
Mm.
It's a process of reacting monomers. Process of reacting monomer molecules together. So I can write simply like this. Let us make it simple. So definitely it is a chemical process. So I can say that in this chemical process, what exactly we do?
Synthesize.
Reaction of monomers. Reaction of monomer molecules. Reaction of monomer molecules. And we react these monomer molecules together with each other.
Hmm.
And what it does is it forms the polymer chains. Formation of polymer chains. So this is the polymerization. So basically polymerization is a chemical reaction of monomer molecules in which the monomer molecules react with together. They form long chain of compounds that we call as polymer chains. And these monomers are lightweight molecules. And the
Hmm.
macromolecules which we get after this polymerization, they are very heavy molecules, bulky molecules.
Hmm.
And because of that bulkiness, they are insoluble in water. And rather, they are insoluble in even the strongest solvents also.
Hmm.
It is very difficult to dissolve a polythene. So now these basic concepts, we got an idea.
So just a second, I'm just making a note.
Yeah.
So this whole lesson is about the synthesis of polymers.
Yeah, polymerization is the synthesis of polymers. That is right. You can say that.
Hmm. Yeah.
Yeah. So now the next important thing which we should discuss, that is like uh, classification of polymers. You can classify it into two classes that we will discuss now. Classification of polymers. So we have something called as crystalline polymer, and we have something called as amorphous polymer.
Hmm.
And these are like very important for us. So let us discuss both one by one. So we have something known as crystalline polymers and amorphous. Now, what is this crystalline polymers? First, let us focus here
Hmm.
in the crystalline polymers. What special property? As the name suggests, they have a good structure. Because crystalline means they follow a pattern.
Yeah,
They
like
have a regular structure.
graphite.
So exactly, we can say that in this crystalline polymer,
There is
it's
graphite a crystalline polymer.
no.
Okay.
Yeah. Right. Sorry. Definitely, graphite is a very strong compound like diamond. You know that the diamond is the strongest, one of the strongest compound exists in the nature. It's so difficult to break that,
Yeah.
and it is made up of carbon only. And you know that the coal, if
Uh,
we just polish the coal,
yeah.
from there only we get the diamond. And
How do you know which is gold and which is diamond?
like coal, you know, na, that black coal.
Yeah, yeah. Gold like the blacker one.
Yeah, the one
But
which we burn to get fuel.
so if you can burn diamond by accident.
No, no. So we have different varieties of coal. So there are some coal which are very hard, very strong. That coal
Okay,
in itself, it contains the diamond.
okay, okay.
So when we polish it, we keep on polishing that coal, we will get the diamond.
Okay.
But it
Okay.
is not a polymer.
Mhm.
Now crystalline polymer we are discussing. Here there are chain folds, like it follows a structure where we can see chain folds, and we will draw one structure, we will get an idea what is the meaning of these chain folds.
Yeah.
And we have a special structure which is known as lamellar structure, and what it is, we will get to know it very soon. So this chain folds and this lamellar structure, they are arranged in a regular manner. Arranged in the regular. So this is the crystalline polymer. So in short, we can say that in crystalline polymer, properties are followed, like a structure is followed, regular structure is there. Now we have amorphous polymer.
Hmm.
Amorphous polymer. Polymers can be in, here the polymers are in amorphous form, and the name suggests amorphous means it does not have a regular structure.
Hmm.
Here the chains are in irregular manner. And chain, what the chain? Polymer chain. Because we know na polymer is made up of chain of monomers.
Yeah.
So that chain of monomer is not following a regular pattern in amorphous polymer. It is following a irregular. So chains are in irregular. So any polymer, if you zoom into it, you will just see big chains of monomers. In crystalline polymer, it will have some specific structure, some regular arrangement will be there. Let us draw one diagram to get more clarity of it. Very quickly, I will draw it to get an idea. Just I may I have any polymer like plastic, you can say that. Any compound I have. This compound, it has some regular structures in it. Let me draw some straight lines to make it more proper. Okay, let me just copy this. Just one second. Yeah. Now I think this one will be. Let me draw straight line will not work. I am just trying to make some regular structures like this. This regular structure which we are seeing, so there are some regular structures available. What it is, what is the significance of it, we will discuss very soon. Very soon we will get a complete clarity of whatever we discussed in the theory. The clarity. So we have some regular structures. And along with that, we have some irregular patterns. Some weird, let me draw it with a different color. Some very weird irregular patterns we will see. We will not at all follow pattern. Some weird patterns. Because these are like chains.
Yeah.
Because when we zoom into any polymer, we will see just chains. So I am making some big chains.
But they're not similar.
They are not similar. Like they are not following any regular pattern. The color, brown color,
Yeah.
they are like big chains, but yeah, they are just random. They are randomly distributed. They don't have any specific structure. But the black chain which you are seeing, they are following a pattern. So from here we can see that these structured regions which we are seeing, these are the crystalline. These are the crystalline lamella. That's the lamellar structure. So we call it lamella. The name of the structure. And this brown thing which you are seeing, it is amorphous region. Like irregular. And so interesting it is that the polymers, they can exhibit both forms. The other big chains of monomers, the polymer chains, they can follow a structure also, they can follow a regular pattern also, and they can be randomly distributed also.
All together, you mean? Like at the same time, or
at the same time also, and at different times also. Like this compound which we are seeing at the same time, in this compound itself, some of the chains we are seeing, it is following a structure. And some of the chains we are seeing, it is not following a structure at all. So in this compound itself, we see crystalline property also, amorphous property also. And we call this structure as, this compound as semi-crystalline polymer. It is a semi-crystalline polymer. Semi-crystalline polymer. Because it is a combination of both. And just if we look at the real world around us, we see very hard plastic, brittle plastic, which if we break, it makes noise. and
Oh
it
yeah,
is
yeah, yeah.
it is very brittle. We see that plastic, so it is fully crystalline. In meaning to say that all the chains in that plastic, they follow patterns,
Hmm.
they follow a geometry, and hence they are
Hmm.
brittle, like we can break it. But we
Hmm.
also see very soft plastic, like the polythene which we see,
Oh, the bags, yeah, yeah.
the poly bags, the polythene which we carry. So if you try to break it, it gets stretched, and you can keep on stretching it. So
That's
that is,
why that doesn't decompose
yeah, no,
easily.
so yeah, 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 that is a different reason, but yeah, that is amorphous. Like all the chains, they are so closely packed in that, like they don't follow any structure. So they are so closely packed, and hence they are very flexible, and it is very difficult for them to like tear. It will
Uh,
keep on stretching and stretching because of this amorphous nature of that polymer. But the
hmm.
crystalline, they are so disciplined, like they follow so good structure that when we break it, it breaks because the bonds, there are significant gaps in between, wherein there is a scope of breaking of the bonds.
Hmm.
So now we got an idea that okay, polymers can be crystalline and amorphous.
Yes, sir.
And if we look at some properties, here it's very fast that it's looking.
Hmm.
So crystalline polymers, if I talk about some properties of crystalline polymers, I can say that they are rigid,
Uh,
very rigid. They are
hmm.
high melting point,
Hmm.
and hence plastics are used in some automobiles also, no?
Yeah, due to the high melting point.
Like the bonnet and all that.
Yeah, yeah.
It is a mixture of that. Like plastic is also there in it, and
Hmm.
that plastic are crystalline plastics. Like they will not easily melt.
Yeah.
Impact resistance is low.
Hmm.
Why impact resistance is low? Because a small force, if you apply, it may break easily.
Hmm.
A small impact and it may break. And on the other hand, amorphous, they are soft
High impact force.
and low melting point.
Well, what about the impact force, sir?
Yeah, it will be low. Well, high. Impact resistance is high. Because no matter how much hard you hit the polythene bag,
Yeah.
it will not break.
Hmm.
But on the other hand, if you hit very hard, crystalline polymer,
Hmm.
brittle that plastic, it will break for sure.
Hmm.
So low melting
Hmm.
and impact resistance is high,
Hmm.
isn't it?
Yes, sir.
Now let us look at some examples. So for crystalline polymer, we have that polyethylene, polyethylene. I will call it like just Please. So example of crystalline polymer, polyethylene. Like polyethylene, and we have PET polyester.
Hmm.
PET polyester. And for amorphous, we have examples like polystyrene, polystyrene. And we have polymethyl, polymethyl methacrylate. Okay, let me write next. It will not be readable. I will write it here. Polymethyl, polymethyl methacrylate.
Hmm.
So this is a amorphous polymer.
Hmm.
Okay, so now we saw different like classification of polymers with it.
Hmm.
So this is clear.
Hmm.
Now we will look into something very interesting, that is the conducting polymers.
Hmm.
And this is very interesting.
Hmm.
Like it is the future, you can say.
Hmm.
Conducting polymers. Let me let us discuss conducting polymers. Let me write the heading. As the name suggests, see, normally polymers are insulators.
Hmm.
Whenever we want to give the example of insulator, we say polymer is an insulator.
Hmm.
And we can see it in the real world also. Like in our daily life, we see that for all the insulations, we
Hmm.
mainly use plastics, the handles and all that.
Yeah,
It
yeah.
is made up of plastic. All the appliances, they have a covering made up of plastics. Even the refrigerator, its covering is made up of plastic.
Hmm.
Or AC, air conditioner, all the outer covering, it is made up of plastic because plastic is an insulator by default. But
So
with rather,
they cover it with plastic because, but it's like the strength is low, right? Like, okay, yeah, it protects, it shields it from, like, say I buy a new car and then it's covered with polymer, like there's a plastic coating, but then like it gets the job done, dust, it prevents the dust, but then um I don't think it's like if I like use my nails or something, it'll easily come off. So it's not that good. Like, what is the point of using plastic?
no. So the idea is that see, the idea is that when we are covering, right, that we have to protect it from outside damage, like outside dust particles, or if iron is used, we have to protect it from rusting, moisture, so many things. That is absolutely right. But along with that, we also have to protect it from conduction. Because let us suppose if, see, copper is so good,
Hmm.
copper, aluminum, they are very good as compared to plastic,
Hmm.
because they are strong also, and the copper and all, they don't get rusting also. But
Yeah, and aluminum is bendable. Yeah.
yeah, but the problem is that why we don't use that problem of earthing. Earthing in that sense that since they are the conductor, if
Hmm.
anyhow there is a leakage, if anyhow if they get in contact with the current, their surface will be charged, and if anybody will touch that surface, he will get an electric shock.
Okay. That is why.
In Yeah, that is why. And in the plastic, it is so safe. In
Hmm.
the plastic, it is very safe.
Okay.
The plastic is very safe. Okay. Because no matter how you touch it, please,
Hmm.
please don't write.
Okay, sorry.
Yeah.
Ah,
So if you touch it also, you will not feel any shock.
but it's the cost, right? Like cost is also a major factor. I thought it was because of the cost.
No, no, no. Cost is second. First is the insulation.
Mm-hmm.
Because just imagine that big appliance, they draw 220 volt or 240 volt AC current. And just imagine the nature of the shock. Like
Yeah.
in North India,
Yeah.
North India, they use coolers,
Uh-huh.
room coolers. So they use metal coolers also. Like
AC, what cooler?
no, no. So cooler is like a very big exhaust fan,
Uh,
and there is a pump also, like which
oh
can draw
yeah,
the water.
the cold water comes, you mean like that?
Yeah, that like that. So normally the good quality one, they are all of plastic, like Symphony, Havels, Bajaj, like all the good companies. But local vendors, they make metallic body or aluminum body coolers.
Sir, I
And
don't get 1 second. Cooler, what cooler? Like the tower type cooler,
yeah,
like the one you stand like inside the room. It's like a standing one. That type of.
yeah, standing.
Okay.
That is right. So it is like a 3D structure wherein this is the front portion, and here you have the fan. Please,
Okay.
yeah. So
So
you
I
have
get
the,
it. Yeah, yeah.
yeah, you have the fan. Okay.
Wait, actually,
So
why are we talking about AC, the cooler
yeah, we are talking about cooler because
conductivity?
yeah, in the North India, like some of the vendors, like local vendors, the body, they uses the metallic body or aluminum body,
Um,
and hence what happens is it is prone to shock, like you can get an electric shock because many a times there is a problem of conducting,
yeah, yeah.
like the leakage
Hmm.
leakage of current through that. People, they experience the shock. And just imagine if small kids are there in the house and if they touch that, it can be very harmful.
Yeah, yeah.
So safety is the one now. Like when it comes to safety, here the companies are ready to charge more and customers are ready to pay more
Hmm.
when it comes to safety. And hence this plastic is used for insulation.
Hmm.
But with some good research, we are able to create conducting polymers. And that is something very interesting, and that is what we are discussing, conducting polymers. So definitely conducting polymers, they can conduct electricity,
Ah,
hence they are called conducting polymers.
yeah.
So the main property of these conducting polymers is that
Hmm.
they can conduct electricity.
Hmm.
Now, how is it possible? Like we have to discuss the chemistry behind that. Like how we were able to make polymers conducting. Because see, the idea is that what is electricity? Electricity is the flow of electrons. And where is the electrons? Electrons is present in the atoms. Now, polymer is also made up of molecules, like a chain of molecules. And those chain of molecules are made up of atoms, small atoms.
Okay. So plastic, but plastic does not conduct electricity,
Yeah,
right?
yeah. In normal state, polymers don't conduct electricity. We have to do some transformation. Like either we have to make it unsaturated or we have to add some external impurities, some ingredients in it.
Mm-hmm.
Then it will be able to conduct.
Okay.
So on that basis, we can classify it like this. On
Mm.
that basis, we can classify it. Mm, Just like this. So we have a intrinsic and extrinsic.
Mm.
We have intrinsic and extrinsic.
Wait, sir, are we talking about semiconductors now?
No, it's not a semiconductor. It's about polymers. In polymers also, especially in the conducting polymers, we have
Doping is there.
intrinsic and extrinsic.
Doping is there.
Yeah, doping.
It's the same thing then. Yeah, I get.
Intrinsic and
Mm.
yeah, that is extrinsic. So in intrinsic also we can classify it into two parts. Like we can classify it as okay. So can you tell me the main difference between intrinsic and extrinsic? Like in general.
Is when it's very pure, like the purity is high.
Mhm,
Because of that, the conductivity is low,
mhm,
and the bonds are like completely full.
mhm.
Um, and extrinsic is opposite conductivity. It's comparatively good. And there is empty bond, so you can, the electrons flow, and both of them, yeah, that is pretty much.
Okay. Yeah. Dope to conduct. We will discuss that. Dope to conducting. And we have extrinsic. Then we have conductivity element, and we have blended conducting part. Now I will give you a clarity of this. What is
Mm.
blended conducting part. So see, the idea is that when any substance will become conducting, when it will have free electrons.
Mm.
Because when it will be having free electrons, then only when we apply the potential difference, it will be able to flow.
Yeah.
That is the logic.
Yeah.
Now the idea is that
Mm.
the free electrons, we can introduce it without adding any external impurity, external atoms or some external processes. Like we can tweak something within the existing molecule itself.
Mm.
That is intrinsic.
Mm.
we can undergo this conjugation. Now, what is this conjugation that we discuss in detail? But with this process, we can generate some free electrons,
Mm.
or we can dope in such a way that doping will not compromise the purity of the polymer. And doping, we already saw that we can generate holes or free electrons using doping.
Mm.
So in intrinsic, we don't compromise the purity of the polymer.
Mm.
But in extrinsic, it's about adding additional atoms
Mm.
to the polymer.
Mm.
Adding additional atoms to the polymer, like that is the extrinsic. To make it conducting. So,
Okay.
so, 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 so we can introduce some conductivity elements inside the polymers, or we can blend the polymer with some conducting materials, some conducting atoms with free electrons.
Mm.
And hence we can get the conducting polymers.
Okay.
So in extrinsic, we change like the physical structure of the polymer itself, because we introduce some additional third party atoms inside it.
Okay.
We make
No,
it impure.
in
Yeah, yeah.
intensity, what do we do? Like we don't change the structure.
Yeah. So in intrinsic, we maintain the purity of the compound, like the purity.
But by doing so, we don't, it doesn't conduct well, right?
No. So there are some techniques. There are some techniques that without introducing any third party atoms, we can generate free electrons.
Then what is the point of doping? So we can use that technique.
Yeah. So the idea is that intrinsic, it is bit like it is not general. General is that it works only in some scenarios. It might be for large scale application. It,
Okay.
it is not enough.
Mm.
But extrinsic is so general that we can scale up. We can scale it up. We can
Mm.
scale it up to
Mm.
whatever extent we want. We can scale it up.
Okay.
That is
Got
the extrinsic.
mm.
Now let us look at some examples of conducting polymers.
Mm.
Okay, so this I think we will do in the next lecture, because we have some important examples that we will do properly. Then
Okay.
we will discuss some very interesting thing, like what is this conjugation, the phenomena we will discuss. Then doped conducting polymers we will discuss in detail.
Mm-hmm.
Then this extrinsic polymers we will discuss. Then we are done.
Okay. So got it.
So this is the last topic. So we just have to discuss the examples and some nature of these intrinsic and extrinsics to some detail we have to discuss. Then we are done.
Mm.
That's all.
Mm. Mm.
Okay, so live stream ended.